Welcome to solverfy.
29.48. So if you look at interference patterns from thin films of like oil or gasoline or whatnot on water, you'll notice that the colors form complete rings. And the question asks us, how are these similar to the lines of equal elevation on a contour map? So on a map, on contour maps, points of equal elevation are denoted by lines. So like maybe this is 500 feet. This is 600 feet or something. Just in case you've never encountered this before. And so everywhere in between the two lines has to be somewhere between 500 and 600 feet. And if you have sort of enough resolution of contours, you can figure out what the slope of the land is and stuff. So for example, where they're closer together, if this is a 400-foot contour, say, here you're going from 400 feet to 500 feet in a very small space, so the slope has to be higher than, say, like out here, where there's much more space between a 400-foot elevation and a 500-foot elevation. And there has to be some locus of points that are sort of form a closed loop that all have the same elevation. If you just think about that, it should make sense. Unless you had some sort of weird, like, actual discontinuity, then these rings should always be complete. If the elevation was some sort of mathematically like pathological function that doesn't really occur in nature, then maybe you wouldn't have closed rings of height for contour maps, but that's not the case. And so for oil films, colors come from varying thicknesses of the film. And you can think of the thickness as being like an elevation. So you might have a region where the thickness doesn't change very much over a large area, and so you'd get a ring of some color that's fairly broad, or you might have one where the thickness changes rapidly, and so the ring of color will be narrower.